Alright, I think I really found the air compression problem completely finished. I'm pretty sure. I'm going to make another video pretty soon, but this is what I have found on this GR16 hop-up. Put some super glue here on this side to try to even it out, because when it goes in it tries to go, I think it was this way. So with the super glue, or was it this way? Yeah, it pushes up, I can't remember, but it's basically there to keep it straight and steady. And I'm probably going to super glue a little bit of thin plastic on there to keep it straight, because it kind of does this in the freaking it's because I think it's a matrix outer barrel, and it's just like, you know, shitty. So I was comparing with this Prometheus, and down in the Prometheus it didn't have a hole that went straight up. So there's the hole that I'm talking about. It didn't have that in the Prometheus. It's really interesting because the other hop-up chambers I have don't have it either. Nothing there. Nothing there. In my test on this hop-up, I was getting, the first time I started working with this gun, I was getting 420-ish FPS, and then this got messed up right here and swapped out to this, and then I wasn't getting consistent at all. This is definitely a little different than this one on size, length as well too, and where the barrel stops. Inside here you'd have the bucking protrude too much, so it'd be like this, and BBs would go up and knock into it, and the air nozzle couldn't come all the way forward. With this one it does, and but I would still get air loss, like crazy air loss. I mean, I was getting like 90 to 400 inconsistency all across the board. And I think I can see why, is that even though I got a good seal on my test, that there is that hole right there and it just bumps up to it. I don't have any idea what that hole is for, but again, I'm using a lot of freaking different parts. This is for the garter. So we've got some G&G parts. This is a garter arm, and we can see it has nothing to do with that hole right there. I'm not sure why that's there. Not sure why that's there, but I'm going to go ahead and plug that up and see what happens. Then I'll get back to you. Okay, gun's working great, and then the selector starts happening again, and obviously there's more to it when something starts to happen again, when you start to have failures. So you kind of go off and look back at seeing what's different that creates an issue with the selector than most guns. And right away I can see something here. This fits in here fine. However, you can see that as it switches over and it's tight in the gear, in the body, it's hitting this gear right here. See that right there? So the axle. So this is going to create a problem where I'm going to have to actually shave down the axle, just because this is already really thin plastic. I don't know if I'm going to get away with it, but you can kind of see the marking of hitting into it. So here's let's kind of clarify here. Let's take this out, dang it. That's full auto, so this would actually be right here like this as full auto. So we can see that that's the reason why it's hitting there. So that's full auto right there. And then when we switch back to semi, just to show where it's supposed to be. So here's semi. Semi should be right here. Oh God, I'm dropping things today. If you look at the gear, there are some indents in it because it is, or excuse me, the selector, because it is hitting this right here. So I'm going to cut that down just a tiny bit, and this should stop bumping in it. And that's probably why the part that was straight right here that was plastic started to bend, become a circular shape, because it was bumping into this gear shaft right there, or the gear axle. So I'm going to shave that just a little bit off down, and we'll get away from this problem. And that should allow this to work the way it's supposed to. I mean, it's working, but then it starts having issue again, simply because you can see right here. Alright, let's move on to the next thing. Okay, after spending some more time investigating, I did a couple things to the tappet plate on the inside. This is an SHS, but the inside I think is a garter. Anyways, so I've cleared this. You can see I just barely cleared it, so I did a pretty good job. And I can see that this should work now, no problem. I can see there's some denting and benting in here on the tip. I think that it was rubbing up against that gear and getting grinded a little bit. Alright, so what I did inside, kind of work on the compression, is right here, this area I shaved down, and a little bit around the edges, because I noticed the inside of the gearbox here is reinforced as VFC. And I think it's a little thicker on the front here, and so it's creating a problem where the this tappet plate wouldn't go forward as much as it would in another gearbox shell. Also, what I did was the back here, this piece, would hit the sector gear axle, and it would stop, not completely forward, it would stop it a little bit, like a tiny bit. So I, on the tappet plate on the inside there, I grinded just a little bit extra off, just a little bit, and then when I checked it, it went a little bit more forward. So, good compression test with the Prometheus barrel. Bad compression test with this barrel. For some reason, the air nozzle, when it goes into the bucking here, it just escapes out the back. But this one has a more solid, so I guess what we're going to have to do is just really try to go for a different bucking setup and a different hop-up chamber, because compression issues can just keep creating headaches, and I understand why there's an issue, but to try to make it perfect is going to be a little bit of what do I say? It's like you'd have to super glue or something around the edge here of this air nozzle. Just to get a better seal to that bucking, or drop out another bucking. But I've dropped out so many buckings and I'm still having a problem. I'm not having a problem with the Prometheus unit, I'm just having a problem with the other unit. So I'm going to hook this back up and see if it sounds a little bit different, since it's not any close to that anymore. Everything else, I checked all the other bearing areas, bushing areas, and nothing seems to be of issue. The piston seems like it's pre-engaging a little bit, but I don't think that's what's really happening. I think the G&G sector against the piston is just a metal hitting plastic, and so many times it's hitting it, it's just wearing down the piston. So it looks like it's pre-engagement, but it's not. So I'm taking that out to really do anything about it. So we're going to go ahead and hook this up and then check it again. Okay. Well, it's in safety. It's working. Semi works. Full auto works. But once I tighten this down here, the only thing that could be happening is the gearbox is coming down a little bit. I had the pin in and it still did the same thing. So what I probably need to do, the only thing that could mean is, since this isn't moving, but the selector plate is, there needs to be a tiny bit more dremelled off the top, like rounded off of the selector plate, probably. Just very tiny bit, and so I can tighten this and then it will work. See, it's working now, but once I tighten it, it's not going to work, simply because it pulls the gearbox down with the selector, and then this will start malfunctioning. So a second issue that I have noticed, so I'm going to go ahead and fix that real quick too. Alright, here's a nice little test to see if you can feed through the feeding hole right here on your hop up. You're going to put this in here like this, sideways, so you can see the hole. Basically like that. And you're going to hold it as stiff as you can to the air nozzle area. And while you do that, and you're looking down that hole, you're going to pull this backwards. You could actually just do it like that. And you go back as far as the gear would put you. So the gear would go back as far as that. Okay. You got to make sure it's tight to the cam. If it's not tight to the cam, it's not going to be true to what's going on inside your gearbox. So here's tight right here. Okay, so we can see that that actually doesn't get pulled back all the way. And as I put this in, I don't know if you can see it, but let's see if I can do this. You can see a part of the air nozzle, so that's not good. So what we'll try here is switch out the tap-up plate, because I did a tiny bit of removal here, and it seems that that might be part of another feeding problem, so we're going to kind of continue from here. Okay, here I am trying to work on the compression issues with this gun. And I think it's a lot more advanced than any other compression problem. So I'm having multiple feeding issues, and I've noticed some things with the body. Here's the CM16 body. I know these for some reason stock, unless they've been revised, the magazines come up in curve. So what that means is, like, here's the stock. This would be parallel to you right there, and the magazine would come up like this, and you have to pull back to get it to be parallel in the body. So in here I have put some JB weld. You can kind of see towards the bottom there and at the top right here, and what it's going to do is kind of position this to be more parallel like that. Here's another body to compare, and before I put the JB weld in, you could see a total difference simply by putting the magazine up. This is one I've never had a feeding issue with. This is an old GR16 metal body. Never had a feeding issue with. So as I slide this up in here, you can see the magazine is flush and straight, and that's not what it would look like in that thing over there. So you can see the difference. This is older, which I don't know why G&G made some kind of screw up, and that is totally screwed up. So if you have that kind of issue, then you'll know what to do with it. But basically, here's what it looked like inside the gearbox, or excuse me, the body. So here's your hop up. This is just a G&G GR16 one. And it presses down on a button in your magazine right here. That button has a shape and also is angled downwards. So if you don't actually touch it flushly, let's say you just barely touch it like this, what happens is you can't get any BBs to feed up, and you're forcing your magazine up. See how I'm trying to force it up? Now here's the example. See, CM16 is angled like this, right? That angle is like this to your hop-up chamber, so you're not getting good feed. When you pull back, see, you pull back, it hits that magazine. I can feel the button being hit, and those BBs will come up in the hop-up chamber. So, kind of easy way to test is to put a hop-up chamber on the front of your gearbox, put this in the body, and see if you can get this to come up straight. So it would be like this. And you can also see if it will hit into your gearbox shell. Now this doesn't go all the way up. There's a tiny bit of gap. However, you can measure pretty much how much that would hit this. So it would hit about like that, which still doesn't give very good clearance for BBs. So an easy modification is to do something here or on the shell here and try to get it to come up a little straighter. Now another question is can it come up that high? Because sometimes the magazine release right here is going to lock onto that and it won't go up all that way anyways. So these are always almost spot on, but they're a little bit here or there. It just depends on your mag. So these are all kinds of I would say complications that could be created, or you'd have to modify to make it, you know, just perfect. So here we go, pushing this up, and now that I'm looking at it, it looks perfect. Before I had this wiring kind of in the way and it was snagging against it. You definitely don't want that. You definitely don't want that when it's in the body. So like if this is in the way, you snag up against that, crunch it, you know, your wires will get clipped and so forth. But usually the wires go underneath like this and away from. So put that to the side here, and you can see, you know, it comes up. And you can try different hop-up chambers, see if something's different here. That's good. So the main two that I'm actually working with are good. Here's the Prometheus one. That's pretty good. Okay, so next thing I'll show here. Also, what I noticed is this wasn't tightened and this came undone a little bit. So this was coming more forward, up, out, and that would create another feeding issue. So I had to tighten that. So you have to look out for things. Okay, so I got that done. Explain that. Now we're gonna look at some tap-up plates here. This is G&G. And this is the SHS right here. Oops, don't you hate when that happens? You hit all the shims off your gear, off a sector gear. Put that back. That is a lot of freaking shims. Oh, that's not cool. They just shot off. Not cool. Hate when that happens. What it is you're just in a hurry to do things, and I wasn't in a hurry to show it on video. That is a lot of shims. Shoot. You can see that is a lot of shims on the top there. So go ahead and close this back on here. There's still more that has to go on top. Wow. Wow, that's really big. It's like looks like 2 millimeters. Okay, there. All right. Another thing I really never said about shimming, but if you check your shims on the top, they should be just about the same from one to the other. It really all, the height at the very top, it all depends when it's closed and everything, but they should be pretty close to the same usually. All right, so go ahead and open this up. I'm going to show tap-up plates real quick, or try to show quick. Videos are kind of long, and condensed with a lot of stuff that may not be useful, but there is usefulness in my videos. So, alright, so here's 3 tap-up plates, one that goes to a DSG, one that we're messing with, and one that goes to my demo box we might use. The back of this one has been just a little bit dremelled off right here because it couldn't go all the way forward. It was hitting a sector's axle, so it couldn't go as forward as it needed to be. Now, how was I knowing this? I was checking by putting on your air nozzle on the tap-up plate right here. I put it in here, and then I would check the seal. Excuse me. You need your top assembly really. So get this on here. Let's get a little bit more oil in here, or grease for the bearing. Excuse me, the O-ring. God, I can't think of words sometimes. Alright. Okay, so you put this in here. Now, some of the things I've noticed is this is reinforced as a R16 gearbox shell. So let's look at this one. And thickness is different. So because of that, we're having a little bit of an issue with the hop-up not going in as much. So we have to be careful of that, because we might not get a bucking seal with the air nozzle. So that's what I'm kind of experiencing now, is the more complex problem. So I have sanded the tap-up plate to go a little bit more forward, and here is the hop-up chamber. Put it on here, and I can see the tap-up plate gets pushed back a little bit. That's a good thing. That is a really good thing. So this is hard on there, yeah. Alright, so here's kind of to show what you would look out for. So we got a bucking here for king arms, and basically this is going to go all the way forward, and it's going to seal to it like this. And while I'm doing this, it doesn't feel very good of a seal. It feels like there is a meshing problem here. Probably because I'm pretty sure this is a G&G air nozzle. This is a King Arms air nozzle. So, or excuse me, bucking. Okay, so here's a G&G long barrel for an M16 stock, and then G&G stock bucking. And there's nothing done to it other than just being put on there. It's just put on. I haven't done anything like any modifications to it. You can see it fits on tighter because these are made by the same company. So this fits on there tighter. When you press down on it, it doesn't really like push itself out. It pretty much stays in position, so you have to push really hard to get it to do anything. But right there, you can see that it would be pretty solid. And that's probably a difference between these buckings, is this is loose on these barrels like this KWA and so forth, and you're just clamping them there, and then when the air nozzle comes in, if it hits it at a certain point, it just like presses up against it and kind of moves the lips a little bit, so you're not getting a good seal anyways. But here we go. So this is the same brand as this air nozzle, and I put this on here, and right away I can see, wow, this is totally different. Look, you could even go in further. Right there, you can see that is a much better seal. It's because brand to brand. Okay, so this might actually be a very good combination, and I might just use this barrel too and cut it, just because it's not being used, and I have a longer, more accurate barrel too. So for VFC stock. So here is the KWA with a GMP hop up and a GMP bucking. So we put this on here, and right away I see a little bit of pushback. So what I'm going to check, again, I kind of showed this, or maybe stated in the video somewhere. I put this in here while this is all the way back, and see if I have enough room for the BB to pass through. So here's a BB for my test. Put this in here, and I drop the BB in. Does it go all the way down? No. Now watch what happens when I let go. You can hear that BB drop, because what's happening is it's hitting this air nozzle right here, and it's creating where it can't go all the way down. So one thing could be done is basically shave off a tiny bit, but then you might have a compression issue, where I've done this before where I shaved it off a tiny bit, wasn't really worth it. So back of that tap-up plate could probably be just a tiny bit more shaved off, but I almost have no more material to even do that, to even stress it out. So I'm kind of complicating what to do here, because next you have the cylinder and cylinder head that blocks from going back, and then you have to worry about your sector gear pulling the tap-up plate as far back as it needs to. So I've added some material on that, or excuse me, your sector cam pulling it back, that tap-up plate as far as it needs to go. So I've added some material, some JB Weld 2-1 that I'm just going to be waiting for 24 hours to cure. Put it down in there, shave it, and it will bring this back a little bit further. So basically that's what I'm dealing with. If I put this in here and I drop the BB down, and I have to use force to push it in, so you've got your what do you call this? Your BB's being forced up by the spring in your magazine. So here, I'll hold this right here, or at least try to. Maybe it's best if I just close the gearbox real quick. A little bit less of an issue. Alright, so close that gearbox. Press that back. Alright, so you can see here if we can push it down, just slightly touch it. It does go in, so maybe we shouldn't do modification. We're just going to rely on a magazine that's really a strong spring to push that in there. Try again. And now it's stuck in there, which is good if like you're shooting it, because you want it to seal into the air nozzle, but or excuse me, the bucking. Dang, what is wrong with my words today? But now I've got it stuck where I have to unjam it, or just blow through it. Yeah. Okay, so try this again real quick. Put this on here, drop the BB in, and I push really hard with force because there's going to be a spring holding this to the gearbox, and just slightly touch it. Yep, it goes in. So worrying about modification would not really be necessary because of that. Drop the BB. You really don't want to get dirt on the BB. Okay, so you put that there. Alright, so we can kind of see these things going on. And that's pretty much explanatory now. So we're going to be messing with that a little bit, and pretty much everything's good to go now. So I'm going to go ahead and put everything together, and then we'll get some more tests done and see what happens. You can see the other compression videos and so forth, but this is more of the seal between the air nozzle and the bucking is kind of an issue. So if your air nozzle is too far away from your bucking, it's going to be like this. And what happens is when you go to shoot stuff like this hop-up chamber, excuse me, this hop-up chamber has an extra hole, I think, to release if there's jamming in your
what will happen is as it presses back from the air nozzle, there's probably like a little bit of a leak or something, just for safety. Like if it jams, the air will leak out in other places. That's my guess, because this whole, like even some people have stated it's maybe to help with the feeding, but I don't think so, because you look at all the other hop-ups, they don't have it. This doesn't have it. Prometheus, this KWA, or excuse me, the GMP over there, I have an Element that doesn't. So we're kind of noticing that what I've seen is the air leaks out there if there's not a good bucking to air nozzle. So that's pretty much it. Go to the next video part.
Okay, I'm pretty much ready to start firing up this gun. I've done some modifications to it. I've put some JB Weld in here and here, and so we can see here that the mag kind of pushes on the air nozzle and the hop-up unit down. So it kind of gives it a little bit, if it's in there straight, should be pretty close. We can see it's pretty good at loading now, but I wonder if before, if it was really pulling it down and causing an air leak. So going to go ahead and test that out pretty soon. I just want to show that it's hooking up straight now because of that. Alright. Okay, a final internal review. I've got everything set. I was using the G&G plastic. You can see over there, plastic hop-up. With the M16 length G&G barrel and G&G bucking, and I believe this is a G&G air nozzle because of the tip. I remembered that the tip is not circular, so it can't really be garter. So you can see that if there's any markings on the tip, it's not circular. It's like a little bit circular, but then there's an X or a crosshair. So an internal report. Basically, I've got the thing to feed perfectly. The feet per second went back up to I think it was 365 to 380 consistently, and I never missed a feed. The burst fire went perfect. Everything went perfect. So I was like, okay, I'm just going to keep dry firing this thing, make sure this thing keeps working, and then I open it up, check it, and this is the second time opening up, and now I have found that the JB Weld didn't hold. Basically, why I put JB Weld there, and I was pretty sure it wasn't going to hold anyways, but I was going to try it, is because the back here is getting indented. This material can't take this hitting anymore. So it is basically making itself a new starting point, and it's going to catch in between the teeth here. You can see it's starting to make its marks in this area, and it's just going to get worse. Piston's going to be unusable, so, or useless pretty soon. So what I've tried to do, is that dirt in there? Yeah, there's dirt in there. What I tried to do was it just kept firing. It seemed to be firing fine, but I'm sure it's not going to be eventually. I mean, I don't know how many more rounds before it just can't feed off this, and then just it's going to break it out. So I need to somehow reinforce this right here, and I'm not sure how I'm going to do that, because the impact of the JB Weld was not very thick, so it just cracked off. Just without it being thick, it's not going to stay right there in that area. So I'm trying to think if I should just add a little bit to the gear and change the spacing. That's what I'm kind of complicating. I mean, I have another piston coming in probably in the next day, maybe tomorrow, maybe today, who knows when. But I could just swap the piston and be all good. So the JB Weld held fine still on the gear. I'm pretty sure that will never be a problem because it's not really impacting it like it is at the top here. We got 2 minutes left on the video, but everything else is going great. So I've gotten rid of the compression issues, and now I'm just trying to salvage the piston is what I'm trying to do, and I've done a hell of a lot of dry firing. I mean, that's pretty much the only way to guarantee that your stuff is reliable, is that you dry fire a lot. So we can see that the back of the pickup here is just taking wear, and the angle of engagement is corrected. The piston is about right here, about right there. So when a spring is pushed in, it makes it about right there, which is very straight to the 12 o'clock position. So it's like this, and then when the spring in, it's like that. So it's not an angle engagement problem. It is definitely a material problem. I'm gonna have to go for now because the camera wants to shut off. It says 0 minutes. I will catch you guys later. So I have fixed the compression, and you've kind of seen what I have done. This will be the end of the video, and I will try to salvage this piston somehow. Catch you later.